All right, so composition, stoichiometry, and concentration. This should be mostly reviewed. We'll add some things with hydrates and other things like that later on, or in this unit that is not reviewed. And concentration, we're talking about molarity, molality, mole fraction, blah, blah, blah. Okay, all the good stuff we've done. Parts per million. Okay, so just composition, stoichiometry. We deal with quantitative amounts among elements in a compound. A couple things in a compound. So this one we're determining the empirical formula, things like that. Remember, you recall doing that from last year? So that is part of this unit. The mole is the core concept to chemistry. The mole is the SI unit for the amount of a substance. One way it's defined is exactly 12 grams of carbon-12, or you could say it's exactly 6.022 times 10 to the 23 atoms per mole. And don't ask me why the mole has an abbreviation. I still have yet to come up with a sufficient explanation for that. I can't come up with a significant reason for that. So molar mass is the mass in grams of exactly 1 mole of a substance. For a substance, the periodic table can be found on the periodic table. For compounds, you have to add the molar masses together, and its units are grams per mole. Here's my nice flow chart to go from grams to moles. You multiply by 1 mole over molar mass, moles to atoms, 6.022 times 223 atoms over 1 mole, and it's backwards on the other way. Remember, in any conversions, our first step is always to take what we know and put it over 1. So if we start with grams, molar mass is a gram, goes on the bottom, mole there. Can we? Sure.
For a review?
Sure.
Okay. Not for a grade?
For a grade.
80% and then
Fine with me. Fine with me. Fine with me. I agree with you. No, 80. Percent composition. Percent composition is what we just talked about. This is like when we talked about it last year. Whenever they're talking about, like I watched an NCIS episode about a month ago. A person's D-link snapped. A Marine's D-link snapped when he was rappelling down the cliff. Abby determined that it was not the same as the one that was produced. Someone handmade it and made it weaker on purpose so he would die. So anytime you're talking about anything with like a person, a chemist, you might watch anything where they talk about a mass spectrometer or anything like that. I forgot I'm on video. You watch any TV shows where they talk about their mass spec unit? No one watched NCIS or probably like Criminal Minds or Bones. Well, mass spec is the big thing that really determines your percent composition. You put a sample in there and you can test it, and it can tell you what atoms are in there, and then you can break it down even more specifically on what isotopes of the atoms are in there. So the percent composition is really easy to find, okay? This is the easy way. It's the mass of the element over the molar mass. So if I'm looking for the percent composition of nitrogen in NH3, okay? Percent composition of nitrogen in NH3, the mass of nitrogen is what? Now, 0.067 times 1 is the mass of the element, because I only have 1 nitrogen, over the whole mass, which is 17.0306 times 100, okay? So 14.067 over 17.0366, 17.0306 times 100. And if I want to do for hydrogen, I'd do 1.0795 times 3 over 17.0306, because ammonia is in H3. So you have to do that part. I apologize. Yes, ma'am. All right, so empirical formula. The empirical formula is the smallest whole number ratio. They may or may not be the actual formula. This is the kind of the other way to determine the empirical formula from percent composition. I'm going to tell you this, what your homework is over tonight. It is a quiz tonight, okay, over percent composition. Your first step is to assume all percents are grams. So if I tell you something's 78% carbon, you start with 78 grams over 1, okay? And then you got to find the moles of each element, the moles of each element. Yeah. And if it's already in grams, you don't have to do anything with it. If it's already in moles, you can skip step 1 and 2 also, okay? So you want to convert from grams to moles, and sometimes percents or something as grams. Then you're going to divide by the lowest number of moles. Okay, so after you find the moles, divide by the smallest number, and then you multiply by a number to remove a decimal if needed, and the numbers become the subscripts of the elements. Common things Really, our big ones here are if something ends in 0.25, multiply it by 4, because you can't have a decimal in a formula, can you? If you had a third, really these are your big ones right here, these bottom ones. These ones up here aren't a big deal. Like for the most part, if you find something to be like 0.2, you'd probably estimate that to be like 0.25, okay? So multiply it by 4. So we can do the same thing from combustion data. So it'll tell you if something combusts, and it tells you how much remains. You assume all carbon reacts to form carbon dioxide, all hydrogen reacts to form water, and all nitrogen reacts to form nitrogen gas or the nitrogen oxide, okay? So our first step of this is to determine the mass of the carbon and carbon dioxide. We won't do this part of it today. But let's work an example. Let's work an example.
So I only get one thing up on one time?
Well, 2, because you wanted the one review from grams to moles.
Because that's not due until tomorrow.
Correct.
Oh.
You have a question? Someone came in and told me I don't think it'd be very rude if someone came in and told you that you're being too loud. It's the worksheet we did last year, okay? Can I highlight this? Control C. I'm trying to do something else. I know. I know I'm good looking. I can't help it. Why it wouldn't let me do that? There's our question. A chemist determines that 1.26 grams of iron reacts with 0.54 grams of oxygen to form rust. What is the percent composition of each element in the compound? Do that written down. We will discuss it. We will work this one apart. Actually, I need to share the screen. Share. I'm sorry. A chemist determines that 1.26 grams of iron reacts with 0.54 grams of oxygen to form rust. What is the percent composition of each element in the new compound?
And is this where it's like the molar mass over something times by 100? Is that this? Which over 1 times the second thing you know about?
Tell me when we're ready to work this out. Everybody ready? Okay, so our first step said to do what? Well, treat percents as grams, okay? But not our first step of our rules of this. Treat percents as grams. We don't have percents, do we? So that step's moot. The second step says to convert from grams to moles. Okay, so Hannah's correct. Take what you know. So you don't have 1.26 grams Fe over 1. Sorry, I made the 1 really small. Times, what's going to go at the bottom?
Over.
Nope.
Yes, it's over.
Nope.
1 mole.
1 mole goes on the top. 1 mole Fe goes on the top. Yeah. What's molar mass of Fe? That's why I'm better than you.
55.8.
Is that this? It's like a Thomas?
Yep. Grams. So someone does. So I just need to convert to moles, so I'm done with this one. So now someone tell me this answer. 1.26 divided by 55.845. Yes.
0.
Well, this is determined the empirical formula from percent composition.
0.0226.
I need 3, so point 0.0.
226.
And that's moles. I can't fit it all in there. All right, so now I need to do the same thing with oxygen, don't I? 0 point, and you convert it to moles. Now, a big mistake most people make is this is not O2. This is just oxygen. So this is just O, okay? Because it's in a compound, it's not an element. So in this step, I'm gonna have 1 mole O on the top. That's such pretty good writing for me until I got to that point. O, erase that, where's the eraser? Nope. Yes, ma'am. Over 15. Point.
I think that's the only thing I remember from last year.
Grade shows that.
Ouch. That's not true.
And that's grams. Oh,
I'm reporting because it's in the notes.
no. That's grams, though. So that's 15.994 grams. So what's the answer?
0.040.
0.040.
That's a lot.
What?
I got 0.
164 divided by 15.
0.54, Seth.
0.54. It's 0.0338. So 0.034.
Yes, you're correct, Hannah. You only need how many significant figures you need in this one? Well, I didn't make my eraser bigger. I think I did. I don't mean to. All right, so it was what point? What 34? So this is moles.
0.34 or 0.034?
0.034.
So I missed a 0 in there. Okay.
So what was it when we had to do here's like 4 different steps. It's the same thing, but just like in 4 steps.
This is it.
Then why are we only doing 2 steps?
We're not finished yet because it was percents were grams. We're just not finished yet. If I think I'm trying to say. All right. So now, what's my next step say to do? Oh, you're talking about stoichiometry. This is that's reaction stoichiometry. This is composition stoichiometry.
Divide each mole by the lowest number of moles.
Divide each moles by the lowest number of moles. So divide each moles. So what's the smallest number? So I'm going to divide each one of them by 0.0. Yeah, let me find my mouse. Everybody see it? Anna, don't eat it. There we go. So now I'm going to divide each one by the smallest number. So divide this by 0.0226. That equals 1. And this as 0.0. What? So now I'm going to be down here. So now my FE, this is just me working from my numbers down here from when I divided, okay? That's not very good.
That's such a whole rule.
F equals 1. O equals 1.5. So now now do I have decimals? So I got to multiply. So what am I going to multiply by? How am I getting rid of that decimal? What's the least common numerator? Or least common multiple of 1.5? So I'm gonna multiply everything by 2 because that'll give me a whole number, won't it? So multiply. So if I multiply one thing by 2, multiply this by 2. So how many FEs do I have now? Yeah, so my formula is now FE
What unit is it?
2. Write my formula. And what about my O? How many O's do I have? 3. That's my answer. That is your answer. That is the empirical formula from percent composition, yes.
Do we need another one?
I'm going to do another one the other way. I'm going to do one the other way. Where is my mouse? Did Hannah eat it? Shane.
Why do you keep asking?
I used to say it's at someone's house. There is my next example. What is the percent composition for by mass for each element in sodium phosphate, which is Na3PO4? I wonder if my smartboard start working. I wonder if my smartboard start working. You're not the one who has to write on this.
I'm not the one who has to read it.
I have to read it as I'm writing. All right, let me know when y'all are ready.
Oh, so now we have to find the formula.
No. Oh, yeah, yes. I'm sorry. I misspoke. We don't have a level, do we, in the robot room? We do? I didn't think we did. Oh, that's one thing we didn't have. All right, we ready to work this? Yeah, I think you're right. Yeah, you might be right. All right, you ready to work this one out? So I'm gonna have to do 3 different problems here, okay? Because I need percent NA, percent P, percent O. So my percent NA is what I'll do first, because that's what comes first. Equals. What's my mass of NA?
Do you not attach the 3?
I do. What's my mass of NA? But I do it in the problem. 22.9898.
22.9.
Now, that's my mass of NA. Now, how many NAs do I have? 3, so I have to multiply it by 3. So that's where my 3 comes in, Hannah, okay? Over, someone needs to tell me the whole molar mass. I ain't working that one out.
68.960.
That's not the whole molar mass.
Of that.
of Na3PO4. What's the total molar mass? Not to the correct number of significant figures, it won't. But you can't do that. You need to look it up on your periodic table because different periodic tables have different masses. And I use the one based, all your test questions, everything always based off of your periodic table. 30.9078, I think.
I got 163.94.
Yeah, that's what I got.
And that's the correct number of significant figures because Na has 4, P has 4, O has 4. Decimals, correct? So it's 163 point, what did you say?
I think it would be 163.941 because that'd be.
I need 4, I'm adding and subtracting, so I need 4 decimals. Because Na has 4 decimals, P has 4 decimals,
Oh, okay. It's 163.948.
9408. And that times 100. And what is your answer? What? Now, there's going to be a lot of significant figures here, peeps. Because let's think about it. That's 6, that's 7, so I need 6 significant figures in my answer. Not 0.42, but you should multiply it by 100. 42, which is a percent. What is it, 06?
06?
But would it be
No, it'd be
97?
7. It'd be 7.
And what's my units? Percent NA.
So it'd be 42.0697.
Percent NA, yes, ma'am. All right, so that's one element. And I need to do percent P. It has 6. 42.0123456. Percent P.
There's no 9.
But it's not, what's the number?
42. Oh, yeah, you're right. It is 30.
I thought you told me that. So percent P. What's my mass of P?
30.9738.
30.
9738.
And how many of those do I have? So times 1. Pretty funny. What's the mass of P?
It's a massive P. You know how much you put in the bowl. P, Riley, urine.
I know. Well, I'll just put your feet above. Yeah.
Toilet
All right.
bowl.
Now this mass doesn't change, does it?
No, it doesn't. You don't want clever?
You do. I'm sorry. Good. Just see if you're paying attention.
Yeah, I got 18.8932. Yeah, 33 actually.
18.
0.8933.
I miss my kids from last year. You didn't let me tell you why I missed them. Let me finish this. Because Nicole couldn't do this problem right now. There was never enough light. She had a solar power calculator. So if the front lights were off, she didn't have enough light to plug it in for her calculator to turn on. So like if you'd see like it'd be a dark day or something like this, she was trying in the back there trying to work it out. She'd have to go stand back there. It was funny. All right, now there's 2 different ways to find O, isn't there? I could do O the same way, couldn't I? 15.99994 times 4 divided by 163. Or I could just subtract 100 minus 42 minus 18%. Get the same answer. You get the same answer, okay? Because they all have to add up to be 100. That's how I would do it. So you're looking at it's going to be right about. It's going to be right around 40%. I need more. I need 39 point what? Percent. O equals,
I got 39.037.
need one more, 0370. Because adding, subtracting, this has 4 decimals, this has 4 decimals. So that I have to have that last thing on there.
Yeah, how did you get, I got 39.1.
I got 39.037.
Riley, your turn to differentiate.
100 minus 42.0967, that's 18.893.
I did 100 minus 42.0697. Then I took that and was like, I don't know, 57 or something. And then I took that minus 18.893.
I mean, you're both doing it correct. It's just who.
I got same as
0370?
39.
I'd say you just type
Oh,
something. Just type something in. Yeah, that's all right. So that is your lesson for today. You have a Google, you have a quizzes, okay? The quiz is over percent composition. You need to make 100 on. I'm not going to make 100 on. Whatever your grade is what you make. The one over grams to atoms, I only need an 80% on it, okay?
That's different.
Yes, I need work on these also. Yes.
On both of them?
Uh-huh. Well, no, I only need work. I don't need work on your 80% one. I need work on this percent composition, okay? And the work, I don't want a hard copy of the work. I want you to scan it and attach it to your Google Classroom and then turn it in, okay? I don't want the copy.
Oh, you were still recording last week.
Yes.